Hi everybody, this is Mr. Raed Al Nusayrat. Today inshallah we will continue in lesson 3.3 grade 12 advanced computation of derivatives, the power rule. We have some learning objective today. Find the derivative of a function at a given point, sketch the graph of a function using the graph of its derivative, and use differentiation rules and higher derivatives in solving real life problems. We have some keywords today also. We have derivative, the tangent line, higher order derivatives, instantaneous velocity, and instantaneous acceleration. Sometimes we need rewriting a function before computing the derivative. So let me check these examples with you. So the first one, find the derivative of f of x equal 3x to the power 4 minus x squared plus 5 over x squared. Here I can do two things. The first one, distribute the numerator over the denominator. And the second one, take x to the power 2 up with negative power. After that, make a multiplication between it and the terms in the numerator. So I will use the second idea, f of x equal, I will take x squared up, so it's x to the power negative 2 times 3x to the power 4 minus x squared plus 5. Now I will make expanding for this. I will make a product between x to the power negative 2 and all terms inside the brackets. So this will give me x to the power negative 2 times 3x to the power 4. It's a 3x to the power 2. Because the powers will be adding. So x to the power negative 2 and x to the power 2 will give me minus x to the power 0 because negative 2 plus 2 is 0. And the last one is 5x to the power negative 2. 3x squared minus 1 plus 5x to the power negative 2 because x to the power 0 will give me 1. After that, I will find the derivative. F prime of x equal 3x squared, the derivative is 6x, minus 1, the derivative is 0, and here 5x to the power minus 2 times 5 will be minus 10, x to the power negative 2 minus 1, it's negative 3. So the final result is 6x minus 10 over x to the power 3. Now, what about the second part? The second part here directly, I will take 2x inside brackets. So f of x, 2x times 4x squared at 8x cubed minus 2x times x, it's 2x squared. After that, I will find the derivative. 8x cubed, 3 times 8 is 24, x to the power 3 minus 1 is 2, and here 2 times 2, it's 4, x to the power 1 because 2 minus 1 is 1. Here we have an application for, in this lesson, finding an equation of the tangent line. For example, here, find an equation of the tangent line to the graph of f of x equal 4 minus 4x plus 2 over x at x equal 1. As we know before, firstly, I will find the slope m, and slope m is the derivative of f at the tangent point, which is 1. So first of all, I must find f prime of x. But when I look here, I have 2 over x. So about this one, I must change the function. Before I have the derivative, f of x equal 4 minus 4x plus 2x to the power negative 1. After that, I will find f prime of x. Derivative of 4 is 0. Derivative of 4x, it's 4 with negative is negative 4. And here, negative 2x to the power negative 2. From this derivative, I will find the slope. The slope is m equal f prime of 1. So minus 4 minus 2 times 1 to the power negative 2. I can find this by myself or by my calculator. The result is negative 6. So the slope is -6. Now, what about the tangent point? The tangent point here, I have x equal 1, so I must find the value of y. The value of y, it's f of 1. So it's 4 minus 4 times 1 plus 2 over 1. And the result here is 4 minus 4 is 0 plus 2, it's 2. So the tangent point now, it's 1 and 2. What about the equation of the tangent line? The equation, as we know before, it's y equal mx minus x0 plus y0. Now x0 and 0, it's come from the tangent point. So this is the value of x0 and y0. So the y equal m, it's a slope, and the slope we find it -6. So -6 times x minus 1 plus 2. We can keep it like this, or we can make more simplify. So y equal -6 times x is -6x, -6 times -1, it's +6, plus 2. So the final result is y equal -6x plus 8. This is the equation of the tangent line for this function at x equal 1. Now we will talk about the competition higher order derivatives. In the first example, we have f of x equal x to the power 6 minus radical x, and we look for the second derivative. First of all, I must change the radical form to exponent form. So f of x equal x to the power 6 minus x to the power half. Now, what about the first derivative? The first derivative is df by dx, which is 6x to the power 5 minus half x to the power -half. Now, why -half? Because half minus 1 is -half. Now, what about d square f over dx squared, the second derivative? I will make the derivative for the first derivative again. So it's 30 x to the power 4. Now, minus half times minus half, it's plus 1 over 4. X to the power -half minus 1, it's -3 over 2. And this is the final result. Also, I can make some more simplifying, 3x to the power 30x to the power 4 plus 1 over 4x to the power 3 over 2, and x to the power 3 over 2, I can change it again to the radical form. It will be the square radical of x cubed. Now, what about the second part from this example? I look for the fourth derivative, because this is the Leibniz form, or Leibniz way to write the derivative. F to the power 4 here, because 4 between two brackets, it means derivative, as we talked before. So first of all, also I will change the shape of the function. So I will start from f of x equal x to the power 4 plus 3x squared minus 2x to the power -half. Now, why -half? Because radical x is x to the power half. When you take it up, it will be x to the power -half. Now I will start from the first derivative, which is 4x cubed plus 6x. Here, -half, -2, it's plus 1. X to the power -half minus 1, -3 over 2. The second derivative, 4x cubed, give me 12x squared. Derivative of 6x, it's 6. And here, -3 over 2, x to the power -3 over 2 minus 1, it's -5 over 2. What about the third derivative? 12x squared give me 24x. 6, the derivative is 0. Here, -5 over 2 times -3 over 2, it will be 15 over 4. X to the power -5 over 2, -1, it's -7 over 2. And the last one is the fourth derivative in Leibniz notation. The derivative is 24 for the first term, and here is -7 over 2 times 15 over 4. minus 7 times 15, it's negative. The denominator is 8, and the numerator 7 times 15, it's 70 plus 35, it's 105. X to the power negative 7 over 2 minus 1, it's negative 9 over 2. If I want to change the last term, I can do like last example. Here we have a real life problem about acceleration and velocity. The function h of t equal 5t squared minus 12t represents the height of an object. Compute the acceleration at time t equal 1. After that, I need from you to make decision about this object going up or going down. I will start from velocity. So v of t equal h prime of t, and the derivative is 10t minus 12. About acceleration a of t, it's v prime of t, or the second prime of h, which is 10. Now, what about acceleration at time equal 1? I will replace t by 1, so I have a t equal 10. It's a constant, so it's the same, it's constant 10. The second idea here, what about the object going up or going down? Really, the object going up or going down, it's dependent on the sign of velocity, the sign of velocity. So about this, I must find the value of velocity at t equal 1. So I will find v of 1. V of 1, it's 10 times 1 minus 12, which is minus 2. Because the velocity is less than 0, so the object going down. So when the velocity is less than 0, the object will going down. When the velocity is positive, the object will going up. Now, sketch the graph of f double prime from the graph of f. Here we have a graph of the function f, and we want to sketch the graph of f double prime. First of all, you must know that you cannot go directly from f to f double prime. You must firstly make the graph or the sketch of f prime. After that, we will move to sketch the graph of f double prime. So I must know some relation between f and f prime. Function f is increasing. That means f prime is greater than 0. Because, as we told you before, f is increasing. That means all tangents have positive slope. That means the derivative is greater than 0. What's the meaning of f prime greater than 0? That means f prime up of x-axis. Also, if function f is decreasing, that means f prime less than 0. So f prime down of x-axis. We can tell you also f is concave up. That means f prime is increasing. F is concave down. That means f prime is decreasing. This information will help you in your sketching. Now we will start and sketch f prime. From minus infinity to minus 1, function f is increasing. So here in this part, f is increasing. That means f prime greater than 0. Also, function f has a vertical asymptote at x equal minus 1. Function f prime also have the same vertical asymptotes. So here I have vertical asymptotes for f prime. And function f prime will be greater than 0 up of x. So I think it's coming like this. This is the function f prime is increasing. So it's greater than 0, sorry. Also, it's increasing. Yes, why not? Because as I tell you here, f is concave up. Look to f, f is concave up. Because f is concave up, f prime must be increasing. Now, what about the third part, from 1 to infinity? From 1 to infinity, I think also f prime has a vertical asymptote at x equal 1 because f has a vertical asymptote at x equal 1. What about f function f here is decreasing. F is decreasing. That means f prime will be less than 0. So f prime is down of x with vertical asymptote with 1. So I think it's coming like this. What about f prime increasing or decreasing? F prime is increasing because also f here is concave up. Now, what about the interval from minus 1 to 1, the region from minus 1 to 1? From minus 1 to 1, about f, I have two things. From minus 1 to 0, this part, f is increasing. So f prime less than 0. In this part from 0 to 1, f is decreasing, so f prime less than 0. So from minus 1 to 0, f prime will be f prime, sorry, here f prime is greater than, not less than, greater than, because f is increasing. F prime greater than 0. So from minus 1 to 0, f prime will be up of x, and from 0 to 1, f prime will be down of x, with two vertical asymptotes at x equal minus 1 and x equal 1. So I think it comes like this. If I talk about increasing and decreasing, as we see here, f is concave down from minus 1 to 1. So f prime is decreasing all the time from minus 1 to 1. This is the graph of f prime. From graph of f prime, I will take the same idea to have a graph of f double prime. Now, f prime is a new function. F double prime is the derivative of f prime. So it's the same. When you move from f to f prime, it's the same idea to move from f prime to f double prime. So f double prime also must have two vertical asymptotes at x equal minus 1 and x equal 1. It's coming here. From minus infinity to minus 1, f prime is increasing. So f double prime will be greater than 0. So I think it's coming also like this. From 1 to infinity, f prime is increasing also. F prime is increasing. So f double prime will be greater than 0. So above x with vertical asymptote with 1. So I think it's coming like this. Why f double prime is increasing? Because f prime is concave down. What about the interval from minus 1 to 1? From minus 1 to 1, f prime is decreasing. So f double prime will be less than 0. So the graph of f double prime down of x-axis. Down of x-axis, it's coming like this. Now, if I talk about why it's increasing here and decreasing here, look here. F prime from -1 to 0 is decreasing and concave up. Concave up, F prime concave up, that means F double prime increasing. From 0 to 1, F prime is decreasing also, but is concave down. Because it's concave down, F double prime, will be decreasing here. Also, you can put this point anywhere you want down of x less than 0. Here or here or here, it's okay. It's just a sample of a sketch. That's it. Now we have a small recap for this lesson. First of all, please don't forget your derivative rules. Derivative of constant is 0, derivative of x equal 1, x to the power n, the derivative n, x to the power n minus 1. Don't forget the derivative for addition and subtraction between two differentiable functions, g and h. So the f prime is g prime plus or minus h prime. And if f equal a times g of x and a is constant, so f prime is a times g prime of x. Also, we talk about an equation of the tangent line. You must memorize your equation here, please. Don't forget this. Y equal m, x minus a plus f of a, where x equal a is the tangent point and m equal f prime of a is the slope. Also, we talk about the relation between velocity, height, and acceleration. V of t, the velocity equal h prime of t, and a of t acceleration equal v prime of t, the derivative of velocity or the second derivative of h. Thank you very much for all. See you inshallah in a new lesson.